Okay, so we're doing more graphing now, and you still shouldn't be using your calculator. And before you listen maybe through the instruction, you should just read through the table, try to complete the table, graph the polar coordinates from that table, or complete the table and do the trig graph below down here. Right, so you should be able to do this no problem. This is from last unit. Pretend this is a y, and this is an x, and this is the y-axis, or this is the r-axis, and this is theta, so you don't need to worry about y and x. So maybe go ahead and graph that trig function right here, and fill out the chart, and try to graph it on polar form and see how you do, and then come back and I'll explain it to you. So pause and fill that out on your own. Remember, here are the ordered pairs, they're going to help. So for example, I'll just get you started. We plug in a 0 for the angle measure right here. 2 times 0 is 0. Cosine at 0 is 1. So 4 times 1 is 4. So my answer here is 4. If I plug in pi over 6, notice that's going to be 2 times pi over 6, which is going to make this equal pi over 3, right? It's 2 times theta. So 2 times pi over 6 is pi over 3, and cosine of pi over 3 is 1/2, and 2 times 1/2 is 2. So go ahead and continue. Pi over 4, you're going to multiply that by 2. 2 times pi over 4 is pi over 2. What is cosine of pi over 2? It's 0. So continue, fill out the chart. If you want to try the polar graph, go ahead, and then check back with me when you're done. Okay, so this is your table you should have had filled out. 4, 2, 0, -2, -4, -2, 0, 2, 4, etc. So as we continue, that's what your table looks like. Your graph below, remember from last unit, this means you have 2 cycles, right? So here's 1 cycle of the cosine curve, here this is 2nd cycle of the cosine curve. So here are my values from 4 to 2 to 0 to -2 to 0 to -2 to 0 to 2 to 4, etc. Now, what we're trying to get you to connect is this this rectangular equation, or this trig equation, connected to the polar graph. What is it going to look like? So that's what we're going to do now. So we have the table of values to try to help you see what's happening. So here we are, this is our angle of rotation. We're out here, we're at 0 angle measure, and we go out 4 units as a radius. As you rotate, so we rotate pi over 6. Pi over 6 is right here. At pi over 6, we're now at 2 units, right? And you can see down here, we started at 4, we went down to 2. So that radius is decreasing in there. So this is going to be curved. It's continually decreasing. So the length was 4 units, now it's a little bit less. 3 point something, 3 point something, 3 point something, 2 point something, until we get to 2. Then at pi over 4, so we continue to rotate. Now we're at pi over 4 right here. We're back to 0. So it's going to curve because the radius continues to get smaller. You can see here until the radius is at 0. From there, we're only at pi over 4. We're still now in this first quadrant. We're rotating to pi over 3. So this is pi over 3, right? 1/12, 2/12, 3/12, 4/12. So this right here is pi over 3. At pi over 3, I'm on this angle measure, but I need to go a -2 radius. So here's a +2 radius at pi over 3, so I go the opposite direction. So here I'm at a -2 radius, so I'm going to continue my loop going down at a -2 radius, but on the pi over 3 angle measure. And then I go to pi over 2. Well, I'm rotating through here, now I'm at pi over 2. But I have to, instead of going +4 radius, I have to go down to -4 radius. So I see that here in my graph, so it continues looping around. Now look, we just completed, right, this first cosine curve right here. We went from a -4 radius, from a +4 radius to a -4 radius, right? So +4 radius, +2, 0, now we're at -2, -4, because it continued rotating through this way. So now we're going to continue with this portion. All right, so now we're in the second quadrant. We're at 2 pi over 3. So 2 pi over 3 is this angle right here, but we need to be at -2 on that angle. So we're here at -2, so it continues curving. So now I'm at this portion of my graph. We're going to do this portion. right? And then I go to pi over 4, or sorry, not pi over 4, but 3 pi over 4, I'm at 0. So 3 pi over 4 is right here, so I come back to 0 at 3 pi over 4. Then at 5 pi over 6, so now I'm over here at 5 pi over 6, which is this angle measure. I'm at a positive 2, so I continue out here to a positive 2 value. And then at pi, here's my pi angle, I'm at positive 4. So that portion continued like that. And now I'm going to do another part of the graph. So here's the trig graph. Oops, sorry, I'm here at positive 4, so I'm here. Then I'm going, or I'll look at my table, right? So I'm at 7 pi over 6. So 7 pi over 6 is on this one. I'm back to 2. So it's curving around. And then I go back to 0. I'm here. Now hopefully you're seeing the pattern and you can continue. At 4 pi over 3. 4 pi over 3 is this angle measure right here. 4 pi over 3, we need to do a negative 4. So I'm going 1, 2, 3, 4. So I'm here. Oh, sorry, did I skip one? I'm sorry, it's negative 2. My bad, I was looking at this. So I'm at 1, 2, I'm here. And then I go to 3 pi over 2. I'm at negative 4. So 3 pi over 2 is here. I've rotated to this one, but I'm going to go to negative 4, which is up here. So I continue my loop. And then at 5 pi over 3, so now I'm in my fourth quadrant. We'll make that purple. So at 5 pi over 3, right now this is 5 pi over 3. Instead of being at positive 2, I'm going to be at negative 2, so I'm here, so it's continuing. Then at 7 pi over 4, which is right here in the middle, I come back to 0. At 11 pi over 6, which is here, I come up to positive 2, and then I rotate all the way to 2 pi, and I'm at positive 4 again. So if I made that all one color, we call this a rose curve, right? So it's a rose curve. It has 4 petals, 1, 2, 3, 4, and notice what is the length of each petal. So we have 4 petals, and the length of each petal is 4 units. Now, how does that relate to this original function? Right? So it says determine where the graph is farthest from the pole. So it's farthest from the pole at 2 pi units, at pi units, and at 0 units, or it's farthest from the pole at pi over 2 units and 3 pi over 2 units. So that is when it is farthest from the pole. Okay, try the next one. Oh, so no, let's look down here. It says use the graphs of r equals a cosine 2 theta below to determine the effect of the a value. So you might have noticed if this has the number 4, you might think, oh, that's the number of petals. Do you think it's the number of petals, or is it the number of units away that it is? Well, let's look. Here the petal length is 3 units. Here the petal length is 2 units. And here the petal length is 1 unit. Notice none of this double angle, they're all 2 theta. None of those changed. The only thing that changed was the length of the petal. So clearly the length of the petal is related to the number in front of the coefficient in front of the cosine, or the number in front of the cosine. Now what do you notice about this 2 theta? How does that relate? Well, that relates to the number of petals, right? So if it's 2 theta, you have double the amount of petals, so you have 4 petals. And that really sums up what's happening here. Now, what is the difference is what we're going to discover now. What is the difference between sine and cosine? So we just did a cosine curve. What happens when we do a sine curve? So you're going to fill out the table, follow that system of what we did above for how to loop around to get those different petals. You know, if you want to graph the trig function first, so you can figure it out, and maybe if you'd like to see that visualization, you can go through that on this polar graph and try to connect the two. Notice these are pi over 12s. Why are they pi over 12? Because when we plug in pi over 12, we multiply it by 2, and it ends up being pi over 6. And sine at pi over 6 is what? Well, it's 1/2. So when we multiply 4 times 1/2, we get 2 there. Sine of 0 is 0. So go ahead and continue, fill out the table, graph the polar equation, graph the trig equation down here, and then see if yours matches up with mine. And then we'll talk about the differences between the cosine and the sine curves. Okay, I tried to color coordinate so you could kind of see how the different parts of the table match up, or color coordinated down here so you can see how the different parts of the sine curve matched up. So remember, we should have 2 cycles of the sine curve between 0 and 2 pi. So one cycle finishes at pi, the second cycle finishes at 2 pi. The first petal, right, started here at 0, then at pi over 12 we go to 2, at pi over 4 we go to 4, at 5 pi over 12 we're at 2, and then we're back to 0 again. And then we went down and did the blue part, and then we did the green part, and then we did the purple part. So here, if you want to graph on your TI Nspire, here are some instructions to do that, although you will not get to use your calculator, but you could check it to see if you did it correctly. So then this is important down here, compare the graphs of cosine versus sine. We gave you the same number in front, the same angle, double the angle. What happened? What did you notice about the pictures? Well, the petals reached their maximum of 4 at 0, pi over 2 pi, and 3 pi over 2 for cosine, and the petals reached their maximum distance of 4 units, which was related to this amplitude right here at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now you're going to continue to experiment. What if we keep that amplitude of 4, but now we have a 3 theta in there, so it's an odd number. So what happens when we have 3 theta? So go ahead and graph, and then graph over here in your polar, and see if you can do that on your own. One of the things I haven't done, and I apologize, you should be doing this, is explaining or showing the direction. So we want to know, because you're going to have this in pencil, you're not going to have colors, we want to know if you understand that you started here at the origin, and you went in this direction. So we want to see arrows along your picture that show, you know, we might ask you to identify the starting point. So your starting point was right there at the polar, at the origin, and then you continued and went this direction first. This is where you started and you went this direction. So then on the cosine curve, let's go back to that one. We started here, right? This was our starting point. And then which direction did you go? So we started here and we went up immediately. Or we started at 4, then went to 2 and to 0, and then we looped around, sorry, like this. Okay, so I'm going to pause. You can continue on with your work and then check it with the results of this when you're ready. Okay, so example 4. Example 4, the difference now is that we have an odd number in front of the theta. So instead of 2 theta, we have 3 theta. We still have an amplitude of 4, right? But now we have an odd number instead of an even number. Let me see, sorry, we'll go back to this one. So here we have an odd number, theta, and then we have an amplitude of 4. So you should have gone out 4, but notice where what part of the graph, so you should just kind of look at this and see if it matches your graph, right? Look at where the red is. We start here, we go around, then we do the blue, then we do the green, but now we're going to loop around twice, right? So we end up looping around this twice. So talk to me, ask your teacher if you're not sure how to do it, and then here is the sine curve. So notice what's the difference, right? So what is the difference between sine and cosine? You still only have 3 curves. You're still going to loop around twice, right? We have a green part, a blue petal, and a red petal. The 4 still tells us the length of the petal, right? And what does the 3 do then? Well, the 3 is how many petals you have. So down here, when n is even, right, then we have twice the amount of petals, that's n, and when n is odd, then we have just n petals. So go back and look, see if you have this, use your calculator. I'm going to stop now. You can check for these other answers down here online, Schoology.